Hello, I'm Illustrious Elucidation. I'm a chemistry graduate and now I would like to try again explaining dark stone parts with the chemistry knowledge that I have. In previous chapter, we learned that Sino was Senku's anonymous NASA engineer mentor through email correspondence. Also, Dr. X wants to be a dictator using the powers of science. They also had met offline, but all they did is that they just stare at an engine rocket together. During the several days before petrification of the entire world, it seems that both were investigating the swallows that were petrified first. There are a lot of information dumping happening in this chapter, like this, and this. Well, I know some of these words. I'll try my best. First, they did surgery on the petrified swallow. Well, from this one panel alone, there are lots of big words thrown around. One of them is X-ray fluorescence, or XRF. XRF is a chemistry analysis method to figure out the elements in a solid sample. We see the results. Not this one. It's just an example of XRF spectrum. In the manga, the result is iron, tiny bit of gold, carbon, and nitrogen. What's that? Some sort of steel? But steels are normally not hydrophobic, isn't it? Well, there are experimental hydrophobic metal, but this one is aluminum. Anyway, for the XRF itself, the basic way it works is that you shoot high-energy light particles like X-rays to make the electrons in the atoms in the sample go far, far away. This is ionization. Then, the electron in the higher energy state goes down and emits another light particle. Since it emits light particles, this method gets the name fluorescence. Different atom creates different wavelength light particles, so it's possible to identify different elements here. Next, we have Senku swapping in the zeolite he used to crack polyethylene from bottle caps with the swallow wing because he thinks both are porous. Now, what is zeolite? Zeolite is a mineral made out of aluminum, silicon, oxygen, and some other stuff. If only Senku got the secret information from CDC that the swallow wing is made out of completely different elements. Anyway, aluminum, silicon, oxygen. You see, in silicate material, aka glass, they make this tetrahedron network of silicon and oxygen. Aluminum can make tetrahedron too, but since they are missing one electron, the aluminum atom is positively charged. There is an acid-base theory that says that acids are electron pair acceptor and bases are electron pair donor. Something that's positively charged can take electron pair, and we have the aluminum in zeolite. So in short, zeolite can act as an acid when it's catalyzing reaction. Zeolite seems like this fancy mineral, but actually it's commonly synthesized. If my university makes synthesizing a particular kind of zeolite as part of the bachelor level lab experiments, then Senku can do it too in his fancy high school lab. For the ZSM5, mix in some silica source, alumina source, sodium hydroxide, and something to make the zeolite grow in proper crystal size. That ingredient is either an organic ammonium salt, which makes the space for the pores, or another ZSM5 acid crystal that has been made already. Just mix all of them, then close them up in a heavy airtight steel container and put it in a furnace for 24 hours. Next, the nuclear magnetic resonance, or NMR. After the polyethylene has been cracked into gasoline, Senku says that he will run NMR and based on the carbon chain distribution, he can tell the depth of the pores of the zeolite, or the swallow wing he used as a substitute. What the heck is NMR now? NMR is another chemistry analysis involving the atomic nucleus, specifically the protons in atoms. Under strong magnetic field, the protons do something different. They now have two different energy levels. Like XRF, NMR also involves energy level diagram. However, the similarities end there. For XRF, the energy level difference is pretty big, so it involves big energy light, like X-rays. Meanwhile, in NMR, the gap is actually tiny, so it involves only small PP lights, radio waves. The proton can absorb radio waves to go to the higher energy, and to go back to low, the proton can emit radio waves. The radio waves involved can have different frequency, which depends on how the chemical bonds around the proton. You see, outside of photons are electrons, and electrons are the one busy making chemical bonds. At the same time, the electrons can also interact with the magnetic field by shielding or de-shielding magnetic field felt by the protons. So different chemical bonds means different radio frequency. Despite the nuclear in the name, there is no radioactivity or ionizing radiation involved. NMRs works in the same principle with the MRI in the hospitals. Enough theory, what happens in Senku's gasoline? Well, initially the polyethylene from bottle caps has only boring carbon chains of CH2, CH2, CH2. So the NMR spectrum of the polyethylene, if you can resolve it somehow, will be like this. After the cracking reaction, we now got shorter alkane and alkene. The difference between CH2 and CH3 is not easy to spot, but there is something else easier to spot, the double bonds from alkene. The chemical bonding here is significantly different, so we have significantly different peak, indicating a different radio frequency involved. The spectrum will probably look something like this, a new 5 to 6 ppm peak compared to the old 0 to 2 ppm alkane peaks. If Senku notices this peak, that means his cracking reaction was working. Oh, by the way, this is proton NMR or hydrogen 1 NMR. Only specific atoms can participate in NMR, and for organic chemistry, usually it's only proton NMR and carbon-13 NMR. All that NMR to see the depth of the pores of the swallowing zeolite. Well, it's a good and logical practice, I suppose. Usually, inorganic chemistry makes catalysts, and to test how good the catalyst is, you test it on a chemical reaction. You want to see whether the reactant and the catalyst you just made makes the product of the reaction. My problem is, why doesn't Senku characterize the catalyst itself? The swallowing zeolite, I mean. If he wants the pore sizes, he may want SEM or scanning electron microscopy. Another characterization method for the swallowing would be XRD, or X-ray diffraction. X-rays can be diffracted by the gaps between the atom in a crystal, just like this laser light diffracted by a tiny hole. Studying the ways the X-rays are diffracted can tell the properties of the crystal, and Senku will probably soon realize that this iron swallow crystal is different to the aluminosilicate zeolite crystal he's usually dealing with. Also, where is he running the NMR? Does this mean that his school have NMR? Damn, that's a fancy school. Which is expected when you can do petroleum cracking in a high school lab with fancy looking tools. NMR machine is big and expensive though, because of the electromagnet that must be cooled using liquid helium. I don't know if the benchtop NMR will be enough for Senku, and yes, there is a smaller version of NMR that uses permanent neodymium magnets. But it's not too great, because remember that NMR involves magnetic field? The magnetic field should be as strong as possible, so the separation between two energy states is big, and the radio waves involved is also higher frequency. So it's the frequency that's easier to detect and the result is clearer. So big magnet equals clearer result. The benchtop NMR doesn't have magnet as strong as the big one. In conclusion, XRF is an analytical chemistry method to figure out the elements from a solid by shooting X-rays and measuring the light particles emitted. The zeolite is a mineral out of mostly aluminum, silicon, and oxygen that can act as acid for catalysis. It's easy to synthesize with Senku's fancy lab, considering that it's taught in chemistry department in my university. The NMR basically identifies which atom is bonded to which other atoms, thanks to some magic involving magnetic field and protons in atoms. Senku should see a new peak around 5 to 6 ppm if his cracking reaction works with his swallowing zeolite. However, Senku should also do SEM on the swallowing after the NMR testing. His school is very fancy to have NMR tool though. That's all I have for now. Since this video is about what Senku did before he was petrified, maybe you want to watch the first episode again? Anyway, thanks for watching.